So this is for 9e, going on from 9c, which we did before. And again, this is the idea of separation of variables. We're using it because there are y's in the differential equation. There also now are x's as well. So we're going to be having to separate x's and y's. So what we're going to do is take all the dx stuff and put it on the right. That's because dx is the denominator, and we want to have basically the dx's up on the top line. So what that also means then is we're going to have to take this 1 plus x squared and divide that underneath on the other side. You can see here we've got a y as well. That's going to come over. So that's a little bit complicated. I'm just going to get rid of the arrows. So we're going to do one thing at a time. First thing I'm going to do is take this over. So I'm going to have dy dx equals 4xy over 1 plus x squared. I'm now going to take the y underneath, and I'm going to bring the dx up in its place, like that. So what I've done there is just a swap between those two things. I'm going to, again, just rewrite that so it's a little bit easier to see. So we have that. And we're going to integrate both sides. Now the left side is straightforward, it's a log. The right side here is a little bit more difficult. So it's one of those ones where you basically think, is it partial fractions? Is it a standard integral? Is it substitution? Or something I can do just straight away. Can't do this straight away looking at it. The only thing we know that has like a 1 plus x squared has to have a constant on the top, and that's inverse tan. So we know that this thing is not going to be inverse tan. The other thing that we could do is then think, okay, well, is it going to be partial fractions? Well, if it was partial fractions, the bottom has to be able to, factor, and unfortunately here, it's not going to work. So it's not factorizable. This is an irreducible quadratic. So what that means then is try substitution. So we're going to let u equal 1 plus x squared. The thing on the bottom here with the higher power is going to be good as u. Then we've got du dx. It's going to be 2x. I'm going to rearrange that so that we solve for dx, which is going to be du over 2x. Like that. We've then got u for our substitution. We've got dx, a little cat nacho. And so now what we're going to do is we're going to replace this part down the bottom with u, this part with dx, and hopefully have the x's all cancel out. So on the left side we've already integrated. On the right side we've got 4x over, this is now u, and dx is now du on 2x. So that's cool because you can see that you end up with a cancellation. You end up with 4 over 2, which is 2, and 1 over u, like that, which is cool. So I've just taken the 2 out the front. So again, now we can integrate. So this is going to be 2 log u and plus a constant. And this is when you substitute your u back in. Now in terms of finding a value for this, we know that we've got a condition as well. So what I might do, I'll just fix that up, is simplify this a little bit. So first thing to do here is probably get everything to be in terms of a log without stuff in the front. So here we've got 1 plus x squared. I'm just going to bring the little 2 up like that. What that means then is that we can take exponents of each side and then get rid of some of the logs. So I'm just going to bring this onto the next page. So by taking that 2, and I might just rewrite that, it's a little bit ugly. By taking that 2 up, it does just make life a bit easier. 1 plus x squared. 1 plus x squared, squared plus c. So we're going to take our exponents now of each side. Oops. Now for this one, you can see here you've got the cancellation, and interestingly with this one, this actually is the same as e to the log 1 plus x squared squared times e to the c. So we could call this a new constant, just call it a, and then we get this cancellation that goes on there with the e and the log. So we're going to end up with 1 plus x squared squared times a. Now what I would be doing here at this point, 1 plus x squared is always going to be positive, so you don't really need the modulus around that. So we can now just basically solve that. So y equals a. Now we don't actually know here because we're taking away a modulus, so we've got the plus or minus there for that case if we're taking away a modulus sign on the left side. So the conditions we've got are y equals 2, x equals 1. Whoops. So let's throw those in. Y equals 2, x equals 1. 2 equals 1 plus 1. Oops. I'll just write 2. So 2 squared. A equals a times 4. So we're going to have a equals plus or minus 2 over 4, which is plus or minus a half. So what that means for our solution in this case is we have y equals plus or minus a half, 1 plus x squared all squared. And with this one you could expand it, but it's just going to be easier to probably leave it factored like that. The last one that we've got here is another solving a differential equation. Again, it's going to be separation of variables. You've got x's and y's everywhere. Now generally with something like this, if you're struggling to separate out the x's and the y's, what you should try and do is factor. Now by factoring you're going to find that you can easily separate out the y's. So for example here, it makes it a little bit easier to see. I'm going to bring the x over underneath. And then I'm going to bring the y under and the dx up. Often with these, a lot of the time you'll end up with a log because you end up taking the y's underneath. So with this one we've got the integral of 1 over y. With this one we have the integral of 1 plus x squared. Now because all of them are over x, that means that each one individually is over x, which actually makes it a lot easier for us to integrate because we're now effectively integrating to find a log and to find x squared over 2. This is x squared on x, which is the same as x. Integrating x, you get x squared plus 2. Plus a constant. I'm going to raise everything up to a exponential. And you've got y. Now, with this side here, you've really got a few things going on. E to the x times e to the log x, and so that's just going to be your x. And you've got times e to the x squared on 2 times e to the c. So what we can do here is we can rewrite this. Let e to the c be equal to something, like an a, and then the rest of it you just leave in that form. So at this point, now we're going to put in our conditions. So we've got two conditions here, y equals 2 root e and x equals 1. Oops. So we'll chuck them in. So 2 root e on the left side. The modulus of x is just 1 is 1. And we've got that. Oh, excuse me. To the power of a half. So we end up with 2 root e equals a root e. So that implies that a equals 2. So therefore, y equals, in this case, 2 x e to the x squared on 2. So that's our solution for our differential equation using our conditions and separation of variables, and same with the previous one. It's all just about using your separation of variables technique, and then once you've done your separation, your integration, then your substitution of your conditions to find your particular solution.